Boy, I don't know about this camera. It's messing up on me. So I'm just finishing this. I've got a little line right here done with the Sharpie. There's the O-ring that I'm going to use, and I like just to put the O-ring on the shaft. That way I can cut it and I can fit it and cut it and fit it and just until I got it where I want it. But I've cleaned up the piece of Teflon. Let's see again. I'm trying to hold my hand behind it so it will focus on it. But you can see that's a pretty nice looking seat, valve seat, and, you know, and it will sit up against that. Got that put in. Let's see, pretty tiny. It should fit in there. Oh yeah, looking good. Okay. Anyway, that's working great. Sealing good there, and it moves. Well, here we go. Get this in focus. Moves pretty easy. So I'm liking that. So is that Teflon? Yeah, that's Teflon. Okay. Anyway, there's packing, just packing inside of that. You probably can't see that, but it's just that rope, right? Teflon rope, and it just snugs up against the edge. So if I have, if that O-ring leaks a little bit, I should be able to tighten this up. I can also use a different kind of a nut here. I can put a nut here that has more space for more packing, which might be important to have. But at this point, now I'll throw a 3 or a 1/4 OEM washer on the back, spring, another 1/4 inch OEM washer. That's a 1/4 20 washer. And then I have some jam nuts. And jam nuts are just, if you don't know what a jam nut is, they're just like a half height, a narrower nut. Let's see, I haven't threaded anything on these threads yet, so I don't know how they're going to be. Well, that's not too bad. Now I can thread this down so that I can adjust this. I don't think I'm going to need a lot of adjustment, but if I need to adjust it more, I can make my threads deeper. But I think, well, that's sealed. Now that's sealed really nicely there. But my idea with this is a jam nut. Now I could use Loctite on that, and probably will, but I will also back it up with another jam nut and then just tighten the nuts together, so that way we're locked up. So there we go. There are my 2 valves, and I built this one the same way. It's 4 pieces here. It's got a bushing that I threaded the inside of. Actually, I turned a fitting into a bushing by threading the interior of it to an 1/8 inch NPT thread. So anyway, so there are my valves. I'll check them. I'll test them, make sure that they're going to work okay. Then the next thing that I want to do is I will want to figure out a way to attach these to the motor. Okay, the way that this works is that this same little push rod that I was using to run the rack, I now built a little gadget here that will, there we go, that's going to push that valve open, and I've got one over here also. Now the one that I have over here isn't lined up very well, so I'm going to fix that one. But this is just a piece of 3/8 inch bar that round bar that I drilled out to 1/4 inch and put a couple tiny little, those are like 440 set screws in it, so that way I could get a few threads wrapped around it. I'm not concerned with having really huge set screws holding this, because the only thing the set screws are doing is that they are holding its rotation. That's all they're doing. This piece back here is some more of the same stuff that I drilled out. So I drilled this out, and I tapped it to a 1/4 20, which is what that thread is. It's a 1/4 20. So for you metric guys, it's like about a 6 millimeter, something like that, roughly. You're probably familiar with 1/4 20 anyway. But anyway, so what I've got is just a tube that I can turn either way, and that the idea is that my little blind screws, my little set screws, just hold the rotation, and this actually provides the brute strength to push this valve open. And that, yeah, I like that. Okay. All right, so I've changed the valves on this, and I haven't adjusted them or anything. I just plugging them in. There we go. That's pretty cool. The thing about it is that if it will run almost, this is almost like maybe 80 RPM. If it'll run this slow, a single action engine, my valves are working a lot better. So I'm really liking that. I could turn the pressure up, but I really don't want to right now. Well, maybe I'll turn it up just a little bit so we can show you what's going on. It's pretty cool. Let me show you what I've got here, and then I'll run through it. Okay. So let's back up. Okay, I've got 2 valves that are in line now, poppet valves, and you can see that my linkage is just a push rod. Little attachment here. I don't want to touch that; it'll take my finger off. There's my exhaust valve. Here's my intake valve. So, anyway, that's what I've got going on here. And that, yeah, I'm getting a really good stiff response. Let's see. There you go. That's my exhaust right there. Did you see that? Just so you can understand how well this is actually working. Okay. I have to time it, but I just wanted to show this to you before I go into a big spiel about what I did. But I do want to tell you what I did. So anyway, let's just take another quick look at it. I'm really pleased. So for those of you that haven't watched what I'm doing here, or you're just new to it, whatever, either way, I've been working on a steam generator, which is right here. It's basically just a coil of wire. Coil of tubing, I'm sorry, with a proper sized burner, and I'm running it on propane right now, but this could be ran on any kind of heat source. I really don't care what the heat source is. It's just that the heat source most convenient for me to use right now is that. So So I've been working on this engine. Let's get this into focus. I've been working on this engine so that I've got a load for that generator. But I also, I do want to build an engine, but I have a couple. I have a couple different things sitting around. I would like to do a turbine, but anyway. So I've been working on this engine, and for over a year I've been thinking about how to design it. As I'm doing my work driving, I have another channel called Backroads of Colorado, where I drive around and I talk, and usually I get cranky and talk about politics, like, you sons of bitches, whoever. Well, I'm a conservative, so you can guess whoever. Anyway, last year about this time, I was driving through a snowstorm up in North Park in Colorado, and I was filming, and actually I've got this filmed. I think it's called Into the Fire. Bad blizzard. It was quite something. But I was talking about the fact that I've been buying a lot of brass, and that I am working on this project, and I had a feeling that the valves were going to be the biggest issue for me to get right. And I think I was right about that. My first idea for valves is this little guy. These are rotary valves. So I started out with a rack and pinion, and I built these guys. Let's see if I can, there we go. So basically there's my pinion gear with a set screw in it and a collar that was originally operating the rack, right? But this is I think it was a 9-tooth gear. I didn't get the adjustment that I needed. I needed more swing, right, in here. So I changed my gearing to a 7-tooth gear, 1, 2, 3, 4, 5, 7-tooth gear, but that still didn't make it work. And these are pretty small little gears. And this is kind of a complicated build, because I've got a lock nut and a washer. Then I've got a little bearing under here that the lock nut holds the gear down to. It actually holds it to the bearing, to the inside of the bearing, so that it turns nicely. But this whole shaft, of course, is locked together. But I've got a spacer. This gear has been drilled. It's really complicated to build, and I don't get the kind of you'd think. I thought that I'd be able to swing these pieces around and get a hell of an adjustment, like to advance and retard my timing. But I really was unimpressed with how poorly this operated. I thought it was going to be great, and I thought that's why I started with it. I thought it would be what I would need, but it did not work at all. So I decided that I needed to do something different, and so I made just a basic regular valve, like a valve you'd find in an engine. I think you call that a poppet valve. So I've got, let's see, I can set the duration of my valve that way, and I can also take the assembly apart. So that's really nice. To set the timing, to set the advance and the retard though, I'll have to actually turn my cam, and that's fine. And I'll probably play with that, but I was real happy that when I connected everything together, it worked as well as it did. Running on a low RPM, that's pretty good for a single acting steam engine to run that well at low RPM. And preface that by saying I haven't really timed it. I just sort of gave everything a generic setting. I just made sure that the valves were being depressed a little bit, and that's basically it. And again, I haven't done anything with my timing as far as advancing or retarding it. And you can see that it started immediately and is operating properly. Get down in there. And you can see the rack is just sliding back and forth here. So that's basically it. And it's running at about maybe 80 RPM, which is pretty cool, especially for, okay, let me, yeah, I'll go ahead and shut it down. Especially for a single acting engine, to run that slow means that I've done something right. I have a lot to do to it, but I'm really happy with the way that it's put together and with the way that it's operating. So anyway, I just wanted to do a little quick update on this particular valve design. I'm really liking that. And the cool thing about that, I did want to point this out. When let me get this camera, I'll change over. The one thing that I noticed about a rotary valve design, okay, here's my rotary valves. They were leaky. Now, I understand that I can make them work and I can seal them up properly, but to seal this valve up, I'm going to need some type of seal that I don't know if I have the ability to make a seal that allows this shaft to turn really smoothly, really lightly, like it is right now. And that's kind of an issue, because when this engine was just running at the speed it was running, using these valves, it would not run, because these valves create so much friction, and that's because they've got to be sealed so steam is not leaking out, and so the compression is not leaking out, right? But to seal them, they're sealed all the time. Every time that rack moves, and the rack moves when the engine moves, so there's always back pressure on that rack, because of the seal needing for, the cylinder, if it wasn't sealed, it would turn freely. But because there's a seal there, it's actually creating a little bit of friction, and that's enough. So that was one of the issues that I realized when I did this rotary valve, that I'd have a hard time coming up with a valve that turned freely and lightly, that held all of the steam and all of the pressure, because that was really one of my requirements. I want to have a valve that actually, well, what I like to be able to do is recycle as much of the water, the working liquid, as I can in this engine. If I have a really loose, crappy valve, I'm going to have to add water to the engine, and it's going to make a mess. And that's not what I'm shooting for when it comes to, an idea of a steam engine. I want a steam engine to be self-contained and to never need more water, or to very rarely need more water. So that was a big drawback to this valve style. It's always a drag. It's always a drag on that engine. I didn't like that. But on this one, it's really kind of cool that it's so much nicer, because the only time that these valves are a drag on the engine is when they're being right there, right where it's being pushed, and that's barely anything. And the rack runs, it doesn't run frictionless, but it runs almost frictionless. So it's really, I think, the better setup. Now, I would not have thought that to begin with, but I'm thinking that now. So I'm liking that. I think this is a way to go. I will time, and I will set. I'll get this. I'll tinker with it and get it set up so that I can operate it at the RPM that I need to operate it at. But I really love the fact that I can run it at a really slow RPM, because for a single acting engine to do that, that certainly means that even though these valves aren't adjusted well at all, I'm sure, they're close enough that this will actually carry itself, it will carry itself through that. It's only getting one push, right? So it's got to carry itself all the way back. You know what I mean, right? The cylinder is pushing one time, and then the whole assembly has got to have enough kinetic energy that it's able to swing back around and trigger that intake valve to push it back again. So that's, like I said, that's why it's so good that I'm able to run that at such a low RPM. Let's go take a look at the pressure that this thing is running at. It's running at about 10 to 15 pounds of pressure. So that is just really cool. That is, I'm happy that it's working so well. But I just thought I'm getting ready to shut it down and start dinking around with other things, so I just wanted to do that. All right. And my calculations with this engine is that, as far as power rating goes, that's depending on how much I put into it, how fast I operate the thing, but anywhere from about 1/3 of a horse to about 2.5 horses, this little engine should be capable of. Now, I don't know if this relatively lightweight build would withstand 2.5 horsepower. It might though. But anyway, that's what I got. Just rough, looking at the rough estimates of the low and high of a 1 cubic inch. Actually, it's a 2.5 cubic inch engine. The piston is 1 cubic inch or 1 square inch, right? That's the two-dimensional diameter in here, 1 cubic inch. When you turn it into a cube, I wanted it to be that, but the stroke is 2.65 inches. So anyway, just so you know, for you people that know about this stuff or want to know about this stuff or are interested, obviously, if you're still watching, you're a steam. You like this stuff. I'll have to say, I'll just point out to you, I was watching a channel. A couple channels. Looks like in the A.E. Kearns, I believe. This kid who is like an amazing steam guy. But also Keith Appleton in the UK. I mean, those guys are the real guys. I am not trying to build a beautiful engine. I'm just trying to get something to work, and I'm just kind of working from the ground up. And I am awed by the skill and the mastery of building that these guys have, building steam engines. There's certainly something really cool to it that I really appreciate. That's not really my goal in building this. I have a different idea for this thing. I think that these could be extremely important things to have, down the road here. So that's kind of where I'm at with it. But all that amazing skill and talent that is out there, that surrounds these steam engines, it's just pretty amazing. So anyway, I am certainly not trying to compete with anyone, and obviously I'm not. I'm just, like I said, this is ground up. I've got a particular use for it. It's not beautiful, that's for sure, but I'm making progress. All right, I'm gonna call that done. I'm gonna try to make a video out of all this mess, and you guys take care, and I'll see you next time.